Oh, hey, my name's Denver. I'm a computer science student at CSUN.
And my name is Renee, and I'm a computer engineering student.
And our project aims to tackle the focus areas of campus involvement and career readiness by solving event discovery challenges.
Yeah, so right now if I want to find an event, I'm constantly juggling between the CSUN website, Canvas announcements, Matador Involvement Center, Handshake, and then bulletin boards I can find around Jacaranda. These are all fragmented sources with really no central hub.
Right, but in-person networking is so important to building those career-shaping relationships. Students deserve a tool that helps prioritize these events more efficiently.
Meet our solution, Olay. Olay is an AI-powered event recommendation tool that helps CSUN students discover campus events. Our application uses a machine learning concept called content-based filtering to match students with campus events. Here's how it works.
Imagine you had a set of two words, music and computer. Take a student at CSUN and a flyer for an event on campus. We want to know how important are these words to the student and to the event flyer. We can use something called a TF-IDF score. All you really need to know about this is it's some scary looking math, but it tells us how important is a word to an event flyer. And once we have our TF-IDF scores, we can represent the student and the event flyer as profiles of these scores attached to their respective words. We then represent those profiles as mathematical objects called vectors. Coming over to this graph, we can see the y-axis is computer, the x-axis is music, the green line represents the student, and the blue line represents the event flyer. When we graph our vectors on the graph, we can already see visually that they're close together, but we want to know mathematically how similar are these vectors. We use a concept from linear algebra called cosine similarity. All you need to know about this is it's some more scary looking math, but it tells us how similar are the two vectors. In our case, they're 99% similar. So we would definitely recommend this event to this student. And as students attend more and more events, our ML model can continue to grow by refining those TF-IDF scores. And that's it. That's all AI really is in the context of content-based filtering.
So, when it comes to ethical considerations, data privacy comes first. We plan to limit our use of third-party APIs so that students' info stays secure within the CSUN network. We also plan to make each student's profile transparent, but only to that specific student. That way students can understand why they're getting the recommendations that they are.
We also want to make sure that our recommendations don't create echo chambers. We'll design our algorithm so that it doesn't push students into narrow groups or cause them to miss out on smaller events. We'll perform regular checks across different demographics and event types to make sure that everything stays fair and balanced.
Okay, well, what does it look like?
Users will find Olay conveniently within the existing CSUN app. This not only promotes user adoption, but supports the continued success of previous student projects. We've imagined eliminating the current event list below the main menu and replacing it with our Olay component.
When students use Olay for the first time, they're met with an onboarding screen. This helps to build a base profile of interest that our machine learning model can improve upon.
When they've completed the onboarding process, students are then immediately met with their tailored event recommendations, including other like-minded students attending the event.
Students can explore their peer profiles, discover shared interests, reach out to connect at upcoming events, and form connections that continue to flourish throughout their CSUN journey. Now, we've structured our implementation plan around 4 stages.
During the design phase, we will collect historical event data and establish ongoing partnerships with CSUN clubs, the Career Center, and other student organizations to keep our event offerings up to date. We will then move forward with designing our ML model architecture and mapping out how it will be integrated into the CSUN app's front-end interface.
Our next phase is development, where we bring the design to life. We will build our model, train it using the data gathered during phase 1, and begin setting up the integration framework. A key objective is to make our project open source, allowing motivated students to gain real-world experience by contributing code. This approach reduces the burden on IT resources and carries forward our spirit of collaboration.
Phase 3, testing and refinement, focuses on polishing the ML model to production-level quality and ensuring our front-end implementation is fully operational.
Finally, we move on to the integration and launch phase, during which we conduct our final quality assurance checks and roll out the solution within the CSUN app.
All right, Renee, I think it's time to wrap this up, and I just want to say, Olay isn't just another tool. It's a way for CSUN students to gain new experiences and grow, personally and professionally.
So, thank you for listening and for sharing our vision of making CSUN more cohesive, inclusive, and collaborative. We look forward to bringing Olay to life and further empowering our fellow Matadors.